map to net zero goal. So I'll just go to hydrogen. Next slide, please. Well, when we talk about hydrogen, we no more talk about hydrogen being manufactured through any other mean than water. So whatever is being discussed about hydrogen is basically is about green hydrogen. And whatever quantity of hydrogen is being generated through natural gas or other sources, these are also to be replaced by green hydrogen by 2030. That is as per Green Hydrogen Mission, Government of India has chalked out in 2023. So when I say hydrogen, it is green hydrogen, and uh, need not to say that the simplest uh, molecule derived, which can be derived from water by splitting it through electrolysis process. And Bureau of Energy Efficiency has given a definition of green hydrogen that this green hydrogen, any hydrogen produced will be considered as green if it is not emitting 2 kg of CO2 equivalent per kg of hydrogen. Well, the very process of producing hydrogen through water electrolysis does not produce any CO2 anywhere. But it is basically this 2 kg is coming from the fact that the electricity which we'll be using will not be always 100% green. So there may be some amount of electricity which will be in fraction in the grid available through coal and other means. So that's why it is defining 2 kg of CO2 equivalent. Otherwise, green hydrogen production does not include any uh, emission of carbon dioxide. And this also does not include any carbon dioxide emission or any carbon dioxide coming out for transportation. So it is only up to production. The place where hydrogen is produced, up to that, this 2 kg CO2 equivalent has been defined for green hydrogen. Next. These are the different ways hydrogen is being manufactured. Through water, it is called green. Natural gas, which is very prominently being used even today for producing hydrogen, depending on the process being adopted, it is turquoise, gray, blue. Then when it is produced through coal, it is brown or black because it is emitting a lot of carbon dioxide. And if we are using nuclear power, it is pink, and whatever hydrogen is available in natural way, that is defined as white. So these spectrums have been defined just to make things very glaring, and green becomes prominent among all. Next. And because India is with a large population of 140 crore, needs a lot of fuel for households, for running industries, for transport sector and all. And it is mostly dependent on imports. So hydrogen becomes a very important and significant aspect in Indian scenario because hydrogen can be produced through what we have, that is renewable power. And this is the only way we can think of reducing our dependence on imports of crude, natural gas, LPG. And today's scenario, because of the war, we can see how disruptive it can become uh, and how vulnerable we are because of these uncertainties. So India's hydrogen roadmap basically aims to foster innovation. A lot of things are to be done, not only in the way hydrogen is produced, it needs efficiencies to be built up. Whatever power consumption is required to produce 1 kg of hydrogen today should be further improvised to reduce consumption of electricity, consumption of water. Then there are issues of which I will be dwelling upon subsequently. There will be issue of making hydrogen available to the place it is to be used, that is transportation, then storage. So all these aspects of hydrogen need a lot of innovations and research. Only then it will become viable. And as it is known, uh, we have very fast reach from $7 per kg hydrogen rate to around $4 per kg of hydrogen produced. But it is still unviable for any industry other than those who are using it purely for their operational requirements. Until it comes below or close to $1, it will not be viable as far as commercial aspects are concerned. So, a lot of innovations are required, lot of efforts are required to ensure that this $5, $4 becomes $1 in coming years, but much before 2030. So, because of these requirements for India, dependence on crude and all, this National Green Hydrogen Mission was launched in 2023 January. Next, please. And basically, it aims at first replacing whatever hydrogen is being produced and used other than green. So that is around estimated quantity is around 5 MTPA. So that 5 million ton per annum hydrogen being produced through other means is first to be converted into green. And then subsequent aim will be to also have some global market, at least 10% of that, which is estimated to be 100 MTPA by 2030. So if we take this also into account, then 5 plus 5, 10 million metric ton per annum should be the target under this National Green Hydrogen Mission. And this will require huge investment to the tune of 8 to 10 lakh crores. It will definitely create a lot of employment. It will also help in reduction of CO2 emissions, estimated to be around 50 million metric ton per annum, which is very significant. And our dependence on fossil fuel import will come down drastically, and we are likely to save uh, more than 1 lakh crore worth of fossil fuel imports by 2030. So it's very ambitious, but then at least on periphery, things are happening. Like green power is now being made available, rates are coming down. Power is available at as low as say 2.5, even 2 rupee per unit. Transportation cost excluded. So cost of production has definitely come down. So we can be optimistic about a day when hydrogen generation will be costing to our goal of $1 per kg. Next. This mission also has put around 19,000 crore rupees to be spent by 2029-30. It will be under certain categories like pilot projects, which few of which have already started. As I told in my last presentation, uh, use of hydrogen in iron steel making has been allocated around 470 crore rupees, and around 9 or 10 pilot projects have already started working on it. These projects have been taken by SAIL, by Jindals, by AMNS and all. So whatever outcome is reached in terms of results, those will be shared among all manufacturers, and Government of India will also be party to IPR, which will be created out of this research through pilot projects. Then R&D has been allocated with 400 crore rupees. R&D is to happen on storage, compression, electrolyzer and all. Then site, strategic intervention for green hydrogen transitions. That has been given a maximum chunk of around 17,500 crore rupees. And it is to have certain PLIs for electrolyzer manufacturing, for production of green hydrogen itself and for production of green ammonia. So this 17,500 crore has been dedicated against various PLI and other schemes. Over and above, uh, since hydrogen will be required in cluster form, like where we have industrial setup, we need to have some hydrogen source available. So the concept of making hydrogen hubs throughout the country will be need of the hour when industry will become ready for use of green hydrogen. So for that also 200 crore has been allocated by Government of India. Next. So now today India is importing around 85% of crudes, 55% of natural gas. So all these dependence will come down once green hydrogen mission objectives are fulfilled even partially. Then it will help in decarbonizing energy intensive sectors, which as I talked about is steel, uh, then production of power itself. So if hydrogen is used as it has been decided, as has been targeted, then it is definitely going to help in achieving our net zero target, which I shared in the first slide. So it is very necessary that uh, work on hydrogen takes place at a fast pace. Then this will also give another advantage because renewables can be produced only during certain period of time. For example, solar power can be generated only during availability of sun. Then wind power is when dependent on the availability of wind and all. So whenever we are able to produce power, we can use hydrogen as sort of storage by producing hydrogen and then using it as energy source. This will also ensure because suppose a lot of power is being generated during daytime and our grid is not able to take that power because suddenly capacity goes up, and it is also not advisable to build such a capacity which is which becomes half during night time. So this generation of hydrogen will also help in grid stability, and we need not to waste a lot of money in designing grid at peak load. Peak load in a sense when we had solar power generated during daytime and other power which is to be generated on 24/7 basis. Next. So as I told, introduction of hydrogen will help in achieving our net zero emission targets of 2070. In fact, if things go well, we can achieve it even before that, as we could do in case of targets which were set for 2025 and now for 2030. So to sum it up, it is not only going to help us in meeting our net zero emission targets, it will also ensure India's energy security. And during difficult days for the world, it is something which we cannot ignore now. Next. Then industries where green hydrogen can be used in a significant manner. One is steel production. In certain manufacturing methods, hydrogen can totally replace coal, and in case of blast furnace and all, hydrogen can partly replace use of coal and coke. And remember that the steel is the biggest polluter in the world. So any reduction in consumption of coal by replacing it through hydrogen will be something very significant in decarbonization. Next. Cement also requires a lot of energy, and which accounts for global CO2 emissions to the tune of 7 to 8%, which is quite big. So here also, if we use green hydrogen as a fuel for maintaining temperature in trains and all, here also we can uh, make a big difference in reducing CO2 emissions. Apart from that, some chemicals are also there which can be produced with the help of hydrogen, green hydrogen, and this will also further help in reducing CO2 emission, making cement production green. Next. Then chemicals, refining, they also need hydrogen. In fact, they are already using hydrogen, which is being produced through natural gas through certain methods. So it remains gray, and our first target will be to first replace hydrogen being produced through natural gas by green. So this will be having twin benefits. One is reduction in CO2 emission, and second is making natural gas available for other purposes. Because pipe natural gas is used for households, for commercial entities, and also for transport sector as CNG. So if we replace this natural gas through green hydrogen, it will help us in two ways. One is by reduction in CO2 emission and making natural gas, the same quantum of natural gas, available for other purposes. For oil refining, it is used for desulfurization and hydrocracking. So what we need is we have to replace this presently natural gas based production of hydrogen by uh, green hydrogen. So use of hydrogen is nothing new. The only thing is we have to change the color. Next. Then petrochemical also uses natural gas in a big way that can be replaced by green hydrogen. Other heavy industries like food processing, then aluminum production, glass production, all these industries are using hydrogen, gray hydrogen at present, which needs to be replaced by green. This hydrogenation process of which is used for making banaspati ghee, that also requires a lot of hydrogen. So these type of uses can be replaced by green hydrogen. Next. Then another important sector apart from industry is transportation sector. Here the real issue is there. We are using all fossil fuels in form of petrol, diesel, even CNG, and they are responsible for around 14% of total emission of CO2 and other greenhouse gases. So, the very way of replacing this emission, eliminating this emission is use of electricity. So EV vehicles have come out as a good solution, but then again EVs have limitations in terms of carrying capacity. When we talk about heavy duty vehicles, long range transport, then EV is having that shortcoming. So what is to be done is we need to use electric vehicles as substitute to fossil fuel dependent vehicles, and also to have green hydrogen run vehicles, which is possible when we talk about heavy duty and long range transport vehicles. So EVs for cars and light commercial vehicles, buses can also be done through EVs, and hydrogen by replacing present fuels in heavy duty vehicles, long range vehicles, including ships. So this is the way. As per data available, 1 kg of hydrogen for a small vehicle gives a mileage of around 60 against 28 miles which we can get through 1 gallon of petrol. So cost wise, but there's a big difference. The two can become comparable only when the figure of $1 per kg production of hydrogen is achieved. Only then the two becomes comparable commercially. Another disadvantage in hydrogen is being very light. Whatever petrol we are able to keep in vehicle, say 60 liter, so that capacity of 60 liter will give us only 5 kg of hydrogen space. So here certain drawbacks are there, but on the same time, when cost goes down up to say $1 per kg, scenario will totally change. Next, please. So I have already talked about heavy duty road transport, trucks, buses, freights. These can be converted, replaced with the green hydrogen powered fuel cell electric vehicles. There'll be no issue with the capacity, payloads, distances once fuel cell vehicles are adopted. Then maritime transport is the biggest, one of the biggest emitter of carbon dioxide, because ships are hauling here and there for months together from place of dispatch to their destination. So here they are using diesel and all. So this should be replaced with hydrogen. And there are certain ways we hydrogen, because again the issue is a ship will be consuming a lot of hydrogen as fuel. So they will be needing a very big capacity. So to create that big capacity, hydrogen can be either stored in liquid form or in form of some other mean like methanol or ammonia. And there'll be one procedure process where ammonia will get converted into hydrogen, methanol will get converted into hydrogen, and ship can continue their voyage. And this will be a big game changer because CO2 emission is a very big matter of concern due to maritime transport. Then in rail transport, though a lot of electrification has happened, but still efforts are being made. And very recently, one trial run has been done successfully on Jind Sonipat route, around 90-kilometer route length is there. And now government is trying, the project is late by 2 years. It was earlier planned to get trial runs completed by 24, but it has happened only, if I'm not wrong, it has happened only in May or April. That is very, very recently. And now with the success they have seen, they're planning to introduce around 35 hydrogen trains at various locations in India. And this is the plan to achieve in a year time. So maybe by 2027, we have hydrogen trains running across the country. It will presently be used only in 90-kilometer, 100-kilometer route only because of that is storage issue I talked about. But with the advancement in technologies, with the more storage capabilities developed in cost-effective manner, these distance covered will definitely improve. Next. Then aviation also is one of the biggest emitter, and here their emissions are more dangerous because planes are flying at height, say 7-8 kilometer or more. So they are directly impacting ozone layer, because any pollutant which is on Earth, it takes time to reach ozone layer and all. But we have already made this 8 to 10 kilometer above. So, and with the very rare density of air there, so that movement of these GHGs becomes very fast to reach ozone layer. So here also a lot is to be done. Here green hydrogen can be used as replacement to ATF. It can be used directly or it can be converted first into synthetic aviation fuel and then used. But a lot of work is also happening in aviation sector also. And maybe 7-8 years down the line, there will be 10 to 20% replacement of ATF by green hydrogen or derived fuels of green hydrogen. Next. Now come to how green hydrogen will be produced. So the very well-known method of green hydrogen production is through water, where we use alkaline water electrolysis method. Here, potassium hydroxide or sodium hydroxide is used as electrolyte. Then we have anode, cathode, as we read in 8th standard, 10th standard. Same method in a commercial way is used to produce oxygen and hydrogen. The only challenge is safety, because oxygen is also being produced simultaneously. So precautions are to be taken when the production is on, so that oxygen, hydrogen, they are separate. And oxygen normally as on date is just being released in air, but it can also be commercialized. Then we have PEM technology, which has come up very fast. In last 10-15 years, it has made a lot of improvement. Earlier, it used to be a very small container type of thing, where very small quantity of hydrogen could be generated. But now they have scaled it up, and now they are talking about PEM in megawatts. And the advantage of this, uh, uh, these facilities can be put up very fast, because they come as module, just like battery. So you can just keep putting one by another PEM module, and capacity can be generated. So suppose we have 500 kilowatt module. So if we put 20, then we are able to generate 2 megawatt. So uh, putting a facility for production of hydrogen very fast, even for alkaline water electrolysis, because here also now modules form have been uh, prototyped by many producers, and they also can also be used as cassettes. You just put those electrolyzers, and production starts. If you want to repair some part, you just take it out, repair without affecting the remaining electrolyzers working. So the process is very robust, fast, and implementation time is hardly in months. Even for 50 megawatt, it can be done in 4 to 6 months. The only time which will be taken will be in enabling works, where we have to arrange power, water, and all. But as far as putting infrastructure for hydrogen generation is concerned, it can be done very fast. Then another emerging way of hydrogen generation is solid oxide electrolysis. This use zirconia, which is basically oxide of zirconium. So this can be used as, and this in terms of efficiency and capacity will be much better, much superior to PEM and alkaline method of hydrogen production. But this is in laboratory stage only, and it may take few years before it becomes commercially viable. Next, please. Then the topic is prospects and problems. So I'm talking about both the things together. So hydrogen, green hydrogen generation is required, but then there'll be challenges in terms of arranging green power. There'll be challenges in storing it. There'll be challenging in transporting it to reach to the place where it is intended to be used. So these are the challenges which needs a lot of technology developments, innovations to make them viable, and to ensure that journey of $7 to $4 ultimately gets converted to $1 per kg of hydrogen produced. So as I talked about earlier also, when I talked about transport sector, 5 kg of hydrogen will need around 60 liter volume, that too at 700 bar pressure. So this is one of the issues, because you cannot store a lot of hydrogen uh, when you are talking about transportation of the same, or when you are using in a vehicle. So this can be to some extent, we can remain in the earlier slide. Please go back to the previous slide. So to mitigate these type of challenges, liquefaction can be given a thought where hydrogen is kept at cryogenic temperature of around minus 253 or below. So this allows storage of lot of hydrogen in liquid form, as in case of natural gas, which is called LNG. So 600 times more volume can be saved when we are putting these gases into cryogenic level. But it has a cost, and you need a lot of power to liquefy. Like for 1 kg hydrogen to be liquefied, you need around 13 kilowatt hour of power. Even for compression up to 350 bar, 700 bar, a lot of power is required, though which is much less in comparison to liquefaction. So you need around 1 to 1.5 kilowatt hour of power for compressing 1 kg of hydrogen up to say 700 bars. So this also in turn adds to power consumption. Then research is going on, and there's a good success also in use of carbon fiber composite material, which are very light in weight, and they can withstand a pressure of 700 bar very easily. So this helps in uh, transporting hydrogen through trailers. This also helps in storing hydrogen as a fuel in a vehicle. So both ways, these type of composite material help, and research is also required to further raise the temperature bar from 700 bar to say 1000. Because more pressure it can withstand, more quantity can be carried by vehicles. And this liquefaction or converting hydrogen to ammonia or methanol are the ways we can think of exporting them also. Because you cannot export hydrogen in a gaseous form because of the the very reason I told, hydrogen being very light. It has a very low density by volume. So you have to convert into liquid form, or you have to convert to ammonia, methanol for transporting it within country or exporting it. Next. Then another way is using adsorption method, where hydrogen can be absorbed by certain chemical compounds or metal hydrides. And whenever hydrogen is needed, these will be released. These will be releasing hydrogen through some chemical reaction or heating method. Another way of storing hydrogen is underground storage using caverns, as is being done for crude or for other petro product. So like India is having caverns to store a huge quantity of crude, huge quantity of petro products to the tune of 35 to 40 days, which was heard in newspapers and in media when this shortage of fuel developed because of war of Iran with Israel and US. So underground storage can also be used for hydrogen storage. So what can be done is we can have underground caverns, salt domes. We can also have we can also use those depleted gas fields uh, from where gas has already been taken out. So these depleted gas fields are good, are having good potential to either store carbon dioxide as a carbon sink, or even hydrogen can be stored, which can be used slowly as per requirement. But research on all these areas which I talked about are required, whether it is transportation, whether it is reducing cost of hydrogen production, whether it is hydrogen producing methods, storage, compression, all these things, all these areas, though technology are available, uses are also there, but some efficiency issues remain, which needs to be addressed to ensure that entire ecosystem of hydrogen becomes economical and commercially viable. Next. Then another issue with hydrogen is it consumes a lot of water. So, for example, around 20 liter of water is required to produce 1 kg of hydrogen. And then water is also required for other related processes. So, on an average, we can say some 30 to 40 liter of water will be needed uh, before we can produce 1 kg of hydrogen. So, when we talk about 5 or 10 million metric ton per annum of hydrogen, you can imagine the quantum of water which will be required. So we cannot think of putting hydrogen production units at any place because getting water, underground water sources are all restricted, and government will not allow this water to be extracted to be used for producing hydrogen. So now what? So to produce such a big quantity of hydrogen, we need to go to seawater. We have to desalinate it and then use it for hydrogen production. But the problem is our consumers are scattered everywhere in the country. So to make this hydrogen available in required quantity and on 24/7 basis, we again need hydrogen pipelines. Hydrogen pipeline is a challenge because hydrogen being a very light molecule, it has a tendency to escape. And if we talk about steel pipelines, which are normally used, it has a effect of induced cracking. So you use the pipeline at high pressure where hydrogen is being transported, and you find that entire pipeline or joints have developed cracks. So it makes it risky, and entire infrastructure becomes useless. So a lot of efforts, a lot of research is being done to find out kind of metallurgy through which pipelines are manufactured, and hydrogen pipelines can be developed and transported from seashore to uh, place of uses. So some success is there. PE materials like MDP, SDP, they are also good to withstand this type of issue of hydrogen cracking, but then they have a problem of pressure. So we ultimately be needing something composite with the steel, maybe in form of lining inside the pipeline or maybe composite material to sort out the problem. And then another is, as I already talked about, through cryogenics. We liquefy hydrogen to cryogenic temperature, and then transportation can be done through ships, trucks, trains, whatever, as is being done in case of petroproducts. So these are the ways this green hydrogen can be produced and then also put to use. Though it is also there that we can make local hydrogen producing facilities by way of having green power source and then producing some hydrogen. But that can be used, say, as a hydrogen fueling station where small quantity is produced and fed. Next. This I think I've already discussed. So such hydrogen refueling stations and localized hydrogen hubs can be produced where water issue is not there. Say for example, Assam. Assam is having a lot of water. Northeastern states have a lot of water. So their producing hydrogen will not be a challenge because water is available. But if we talk about North India and all the remaining part of the country, other than those who are having seashore, it becomes a problem. So decentralized distribution models can be adopted, but in a limited manner. And as I talked about hydrogen fuel cell vehicles, these will be happening very soon. Prototypes already been made. Some trucks are being applied by, I think, Reliance as part of their R&D process to make them more and more robust. So things have started happening. In Delhi, Mr. Gadkari uses the hydrogen fueled car also. He is using it for last so many years. So one fuel station is also there. Then Indian Oil Corporation has done a lot of research in this hydrogen fuel cell vehicles. Another way which I forgot to mention is blending hydrogen with natural gas in pipelines. So that is another way. Like if you cannot use 100% hydrogen transportation method, then we can mix it with natural gas to certain extent, 4%, 5%, 10%. And then hydrogen rich natural gas can also be used. Dr. Kailas, you have some question.
Yes, sir. Actually, I'm working with the green hydrogen projects with the project management consultant
Hmm.
to RISA. There's a green hydrogen hub at Gopal,
Hmm.
Tata SCZ.
Yes, yes.
So I have two questions here. One question is about the water which you were talking about.
Hmm.
Desalination of water is a one option, 100% right. But how economical viable it will be, because that also will add the cost to the project.
That's
Is
true.
what?
But then the PEM method, I have been told,
Yeah.
PEM method is able to directly use the seawater.
Uh,
Though it will be costly, it is still
Again,
not commercialized. But
yes,
I met
yes.
one of the manufacturers. So
Mhm.
he told that saline water can also be used, uh, and with there'll be comparatively less cost and less power consumption in comparison to going with DM water, that is demineralized water.
You are right, sir. But it is still actually its credentials are
Yeah, yeah, yeah.
not in
It
yeah.
is still in that R&D stage. People are making a lot of
Yes.
claims. You must have
Correct.
seen since you are there in the business. What
Yes. Yes.
people say and what actually happens is different.
Correct.
Take
Correct.
example of EVs. EVs may somebody said that this vehicle will give mileage of 600 kilometer. But then later on they clarify, no, no, if you run it in the city, it will give
Yeah.
80% of that. And if you go in express and highways, it will give only 50%. So when
Yeah.
I purchase a vehicle thinking that I will be going from Delhi to Kanpur with my EV fully charged, the answer is it will not take me to Kanpur directly
Correct.
because entire power will get exhausted somewhere, say 70-80% of distance traveled. The
Yeah.
reason will be the speed, the way
Yes.
power will be extracted. So these things are always there. When some new technology
And
comes, people don't tell the truth. People tell
yes.
something mix.
Yes.
Same
Yes.
is true with hydrogen also.
And my second question is about the use of, or rather, the small micro level projects of green hydrogen. Like if you say the biofuel and biomass pellets and all this has actually revolutionizing the energy at the rural level. So, is it possible, or do you have any this thing case study where it is being used at the micro level? By farmers or by somebody, because
And
in
they
some
are,
countries,
I'll tell you, I'll tell you. Actually,
yeah.
good thing is this National Green Hydrogen Mission has
Mm.
also talked about uh, this, say, compressed biogas. So any
Yes.
biogas which is used to generate hydrogen. So the
Yeah.
hydrogen generated through biogas will also be considered as green. So
Exactly.
now we
Exactly.
are having so many CBG plants.
Yes.
Many are there, many are coming up. So if we
Correct.
produce hydrogen from that, so that will
Mhm.
also come under category of green. The only thing
Yeah.
is where you will use it. So at the
Mhm.
stage where we are only talking about it,
Yeah.
and the quantity which will be generated will not be very substantial. So these
Mhm.
things are there, but then efforts are to be made. So micro level
Ah,
answer is yes, it is there.
yeah.
It comes under the definition of green hydrogen only. But the thing is, who will produce it and how they will produce it and why they will
Correct.
produce it.
Correct. Actually, one of the consultant from Japan, he was talking about that they are decentralizing the green hydrogen production at a micro level, and there are some pilot projects running there. So that's why I'm just checking whether
Mm.
where we are in India right now, because
India is
this may
also having
be,
pilot projects. Now it must be operational. NTPC did one or two with
no,
ECME.
that
So they are
these are
there. So these are
Sir,
there, but then
no, these are
very
the big
very
projects.
limited.
I'm talking about small projects in a rural setting. एक किसान ने एक ग्रीन हाइड्रोजन का छोटा एक प्लांट लगाया, वो that type of things actually I'm
That
talking.
type of thing is possible,
Hmm.
but the cost and the usage,
Yeah.
these issues still remain.
Okay. Okay. Thank you, Dixit sir. Thank you very much.
My pleasure. So I think we are very close to our presentation, and it is almost over. I was just talking about blending of hydrogen with natural gas. So I'll just add one more thing. Indian Oil has also done one pilot project with the in the Process Gas Limited (IGL), where they were using uh, HCNG, they call it, CNG blended with 18% of hydrogen. And as told by them, it increases mileage, and definitely if it is used in a big manner, then it will also be sort of substituting at least 18% of natural gas by hydrogen. But I don't know why this has not been taken further. So only one plant was made, which is also now non-operational. But blending of hydrogen with natural gas for city gas distribution projects is on. In Ujjain, this Avantika gas is running one a unit where they are blending 2 to 3% of hydrogen, and it is running successfully for last now more than 3 years. So that is all from me. Now we can enter into question answer session.
Sir, hydrogen needs lot of safeties and precautions. Is there any mission for national green hydrogen mission?
I'll tell you. I'll tell you.
Guidelines for
See,
training for people, those who are working
no,
around.
no. Answer is big no. For LNG, for hydrogen, unfortunately, actually, in हम लोगों की problem क्या है? We learn only when something happens. But good thing is hydrogen is already being used, and as I told you, huge quantity of hydrogen is being used in refineries, in hydrogenation plants of food product manufacturers at many places. The only thing is it is not green. So as far as handling of hydrogen is concerned, and it is also being transported through uh, uh, truck trailers where cascade of steel cylinders are being used. So handling of hydrogen at high pressure, which is around 300 bar, decompressing it, using it for the processes is still on. So India knows how to handle hydrogen because hydrogen is not new for industry. But when we talk about the commercialization at that level where there will be vehicles operating through hydrogen, uh, all plants will be having a hydrogen producing unit where oxygen and hydrogen both are coming. See, that is one risk when we talk about production of hydrogen through water. In methane process, it is not that risky. But when we produce through water, we have to be careful. But then need not to worry, technologies are there. And apart from that training part, everything is okay. अभी capacity भी नहीं है. That green hydrogen capacity is almost negligible in India as compared to gray hydrogen. But this is one topic which is to be taken care of, and we need to learn a lot because hydrogen is a bomb. If it leaks, it will explode. So that aspect has to be taken care of. But then, since industry is using hydrogen for decades now, so they know. And I visited one of the plants. They put all those precautions, and I've seen it is very safe, operational. But the thing is, it will not give you any warning. हाइड्रोजन में कोई स्मेल नहीं है, कुछ नहीं है, और suddenly a fire comes. So that accident will be very fatal if it happens. So precautions are to be taken.
Thank you, sir.
Hello,
Anybody else?
I'm Uday Kumar.
बताइए.
Hello.
बोलिए सर.
So, see, you are talking about green hydrogen in rural areas. So we ourselves have designed a small equipment which can separate hydrogen from a gas mixture. So the equipment can be used,
from biogas.
yeah, that can be used in gasification process or in SMR process. So in both the form, the hydrogen can be extracted.
See, extraction of hydrogen is not an issue. From methane, we are already extracting hydrogen. That is
No,
called gray
separating
hydrogen.
hydrogen from the
And from
gas.
biogas, after processing it, removing sulfur, water content and all, it becomes methane, and then processes are known. The only issue which we discussed, what to do with that hydrogen. If you have
Yeah,
something
so
to talk about that.
what happens in the SMR reaction, you get three, four gases. Like
Mhm.
when methane mixes with water at temperature and catalyst, it will release not only
Mhm.
hydrogen, it will release carbon monoxide, carbon dioxide,
Yes, yes.
and hydrogen. So in this gas mixture, so hydrogen has to be separated to get a pure hydrogen.
Mhm.
So we made a equipment which can separate hydrogen, and
Okay.
now like it can be like we can use like if we are using a gasifier, we can use pellets, briquettes, or we can use direct rice husk stick for a gas in a gasification process.
Yeah, that's true.
So, but what the problem is funding. Like banks never consider to fund such projects. They are afraid to fund like this project. So we've been approaching various banks with this project report, but it's like very hardly banks take such new projects. That's a big
That's true. See, for CBG, government has come out with the for compressed biogas, government has come out with many models. They are promoting in a big way. Loans are available. So if you ask for loan for CBG, if you ask for subsidy and other things for CBG, it will be available. So you should first go for CBG, establish it, and it should be near some CGD entity who can purchase your gas in CNG form or PNG form. And then you add, after successfully starting this CBG part, then you can think of going into hydrogen in next phase. So then your product will become bankable also.
yeah,
Because
true.
otherwise, right from husk to hydrogen, nobody will give you any loan,
Yeah, yeah,
including me who understand the subject. So
true,
you
true,
do it
sir.
in two parts. One is go with CBG and then switch over to hydrogen.
Sure, sure, sure. Thank you, thank you.
And you can contact me through ECI since I have worked on it. And maybe we can put this CBG presentation also one day where we can discuss things in detail. युवराज जी आप इसको नोट कर लेना कंप्रेस बायोगैस पे भी हम लोग एक टाक कर सकते हैं.
Sure, sure, sir.
So,
Sure,
excuse me, I'm Gopakumar here. I have a question. Whether is there any ready reckoner for cost comparison of different methods of manufacturing green hydrogen?
Well, green hydrogen के लिए सी major component is power, green power. If water is free, then the only cost is power. So if your power is cheaper, your hydrogen producer is cheaper. So one study says if we are able to provide green power below 2 rupees, in fact it talks about 1 rupee 80 paise, then green hydrogen produced will be very close to $1 per kg. अब ये डॉलर क्या रुपए से मत कंपेयर करिएगा बिकॉज रुपया इज गोइंग हेवेयर इन कंपेरिजन डॉलर, तो दैट्स व्हाई आई एम टॉकिंग अबाउट डॉलर. तो इफ वी कैन डू दिस देन जॉब इज डन. तो मेन कंपोनेंट रिमेन्स पावर ओनली. आपका जो भी कैपेक्स है, जो भी बजट आप प्लांट लगाने में करते हैं, उसके बाद 70% कॉस्ट इज इलेक्ट्रिसिटी ओनली.
Any cost of plant is there actually any cost of the plant for this many kg of
Well, we did one feasibility for IGL. We talked about some 20 megawatt, 20 megawatt, and 10 megawatt. Total at three locations: 20 megawatt hydrogen plant, 20 megawatt, and 10 megawatt. अभी मैं cause भूल गया हूँ because we did it long back, but I can definitely tell you.
Okay, thank you, sir.
हेलो, एम आई ऑडिबल?
Yes, yes.
हाँ प्रद्युमन जी नमस्कार, मैं गौरी शंकर दुबे बोल रहा हूँ।
गौरी शंकर जी नमस्कार।
नमस्कार। कुछ 21 स्लाइड में काफी नॉलेज शेयरिंग हुआ है, बट बीइंग स्टील मैन आई वुड रिक्वेस्ट टू थ्रो सम लाइट about use of hydrogen, green hydrogen in cold rolling sector, blast furnace sector, and steel melting sector.
I'll begin with blast furnace. So one pilot project has been taken up by SAIL at their
Yeah.
Bokaro plant, where their blast furnace number 2 is being used for this purpose. So what they will be doing is they have done DPR, DFR, they have all made, and they will be very soon starting experimenting. So what they will do is they will be injecting hydrogen at different percentages to begin with very small quantity and all. So they
Sure.
will be seeing what effect it is making in their overall process. Because hydrogen में क्या होता है, it is endothermic जो reaction है, तो cooling effect भी आता है इसका. So those aspects are also to be seen. In blast furnace, it can replace coal to some extent, but it cannot do 100% reduction process in blast furnace. That is also for sure. So coke and hydrogen both will be ultimately in a blend will be the way blast furnace will be making steel, and it can reduce the carbon emission from present day of 2.5 ton per ton of finished steel to close to 2. Then DRI, yes, DRI can use almost 100% of hydrogen. It can use the blend of coal and hydrogen also. So in DRI we can do. Apart from this, hydrogen can be used as a fuel in a steel plant where you need heating, where you say for reheating furnaces and all. So there it will be simply used as a fuel to maintain temperatures. And for certain processes like annealing or bright annealing process के लिए hydrogen can be used. So these are the applications I foresee in the steel sector. But if it is done, if it is implemented, we will be definitely moving towards green steel.
Thank you, sir. Thank you, thank you, thank you very much.
My pleasure, Dubey sir.
Good morning, sir. This is Vijay Chandran Nair. Actually, it was a very nice presentation as far as this hydrogen pros and cons is concerned. And I am having two doubts regarding your presentation. One is regarding, you already told that from saline water we can produce hydrogen. There is no problem. At least I am thinking this maritime transportation sector we can make use of this hydrogen because it is traveling and staying in the plenty of seawater. And you already told that PEM method of that means production of hydrogen is also feasible in saline water. What is the condition of R&D in that particular area? That is question number one.
Well, let me answer this question first.
Yeah, please.
So those PEM manufacturers, one of them claims with some modification, because see, ultimately, why we do demineralization? We do it to meet requirement of electrolysis. If it is having lot of impurities, it will hinder the process. Ultimately, it is movement of ions from cathode to anode, right? So the very purpose is to get rid of those impurities so that movement of ions is not inhibited. PEM being slightly different, what PEM is doing, it is using a membrane. So it is only allowing hydrogen ions to pass through, and remaining it is able to retain. So the only thing is that membrane will have no shorter life. You need to replace the membrane more than once because you are now using seawater. But the process in it is not like the one I talked about, electrolysis, alkaline one. It is only using membrane, so it is possible. So when he claims it is possible, I agree. I tend to agree, but it will increase the cost because abhi manufacturers of this film are very few, and it is a patented product. So they are charging exorbitant. When production of PEM modules increases, cost comes down, then these things will become feasible. What you are trying to say is maybe we install PEM in ship itself, and hydrogen is produced, and my ship is sailing.
Yes.
That may happen in future, but right now, if we liquefy hydrogen, store it as a fuel in our ship, it can do the job. But it has a cost. As I told you, something of $5, $6 per kg in comparison to existing fuels. They're just not comparable. Your voyage cost will become 3 times more.
Correct. And the first beginning itself, you have already mentioned that actually it is half is only true and half is myth. Like that, you already told that.
At least as far as I know, this update I took more than a year back. Maybe something has happened. I have not updated myself, but then this is the issue. Things are maturing, but things are happening very fast.
Yeah, right. My second question is, you already mentioned that natural gas is mixing with hydrogen, some 15% of hydrogen, and we are transporting it. So in that case, that natural gas plus this hydrogen gas, which is used for this transportation sector, when we are using for transportation, whether it is possible to use for this transportation sector is possible or not, that is number one. Number two, if it is able to use in transportation sector, whether we can change or any modification is required for the engine, that is another thing.
Well, I tell you, there are two aspects. One is I talked about HCNG. CNG blended with hydrogen, 18%. So that pilot project was done in Delhi, Indraprasth Gas Limited and Indian Oil Corporation, and they did it for a few years. So they were filling many vehicles with HCNG, and they found good results. I don't know why this was discontinued. This maybe I can find out. So, but it is possible. Without making any major modification in any vehicle, HCNG could have been used as they were doing. Another is blending hydrogen in city gas distribution network. But there we are talking only about 2% to 5%. The reason is components of compressor, components of pipeline, meters, regulators, all those things have still not gone through that hydrogen molecule. So how it will behave was not known. So Avantika Gas, for last 3.5 years, they are blending 2% of hydrogen into their network, and they are monitoring health of various components. So far in last 3-4 years, they have not found anything adverse. So 2% can be said to be a safe limit. In certain countries like Italy and all, they say 5% blending is also okay. It will not harm any meter, any regulator, any valve, pipeline, compressor components and all. So 5%, up to 5%, it is definitely doable. Beyond that, results will be required.
Great. Thank you so much. Yeah.
Okay, Mr. Vijay.
Actually, in the vessels, this ship vessels, is it possible to generate electricity through wind or solar and then convert to hydrogen from the water? Any project done like that?
See, solar will be possible, but then it can do very little. Space is a constraint. In ship, you have certain area only which can be put with these solar modules. So it can generate very less quantity of this green power, and then night time it will do zero. Wind also, that needs a lot of space. So the kind of the quantum which will be generated, that is not motivating enough for them to go for it.
Is there
अब आप
any
50 यूनिट 60 यूनिट प्रोड्यूस करके आप क्या करेंगे?
is there any data for 1 kg of hydrogen? How much power we require?
Well, yes, as I told you, I think I told you in between, or I did not. Let me just recall. I noted it somewhere. Just 1 minute. Give me half a minute. Water, I told you it needs 9 liter demineralized water, overall around 20 liter. Then, yes. Alkaline uses around 50 kilowatt hour, and so is PEM. So around 50 kilowatt hour is used to produce 1 kg of hydrogen. That's why I said, if you can reduce cost of electricity, you have reduced cost of hydrogen.
Okay, thank you.
And now research is going on to reduce this 50 kilowatt hour at least by 10%. The solid oxide electrolysis process uses around 10 to 15% less power, but then it is in only lab stage, so it will take a lot of time. Then compression will take some 1 or 2 units. Liquefaction will take 10 units. But that is transportation part. As far as generation of hydrogen is considered, around 50 kilowatt hour, that is 50 unit of power per kg.
Thank you, sir.
Yuvraj ji?
Sure.
So we are close to our session. आज क्वेश्चन आंसर्स अच्छे थे, अच्छा लगा हम लोगों को।
क्वेश्चन आंसर हो गए
और
आज।
चूंकि ये इमर्जिंग एरिया है, हमारे जितने भी प्रोफेशनल इंजीनियर्स हैं उनको कम से कम सब्जेक्ट का कुछ भी पता रहने से क्या होता है ना, दे रिमेन रिलेवेंट फॉर फ्यूचर। उनके दिमाग में क्यूरियोसिटी रहती है, अपडेटेड रहते हैं। So it is very
Actually, क्या है दीक्षित साहब, the basic thing is you have to extract hydrogen from the nature, whatever water से जो भी extract करना है, stock करना है, और as a catalyst और as a composition दूसरे chemical के साथ मिलाकर जितनी compound बनाना जहां जहां लगने का है।
Right.
This is the basic thing sir. Question क्या है, handling is very difficult, तो ये सब precautions लेने हैं। These are the things which are the basic things in it.
Correct.
So far I understand. और बाद में तो
बिल्कुल सही है। हैंडलिंग इज वेरी इंपॉर्टेंट, वेरी
Very
क्रूशियल। ओनली थिंग इज हाइड्रोजन की हैंडलिंग हम लोग करते हैं, बट व्हेन वी टॉक अबाउट प्रोड्यूसिंग हाइड्रोजन पर्टिकुलरली
Yes.
थ्रू स्पैम इलेक्ट्रोलिसिस, उसमें क्या हाइड्रोजन ऑक्सीजन दोनों प्रोड्यूस होता है।
दोनों प्रोड्यूस हो जाते हैं ना,
इट वेरी
ऑक्सीजन भी
इंपॉर्टेंट कि
प्रोड्यूस हो
दोनों को हमको दोनों की दोस्ती नहीं होने देना है।
हाँ,
दोस्ती होते ही देयर बी
हो गई तो बस खत्म। दिस इज ऑल द प्रॉब्लम।
एक एक्सीडेंट बोकारो में हुआ था। दिस प्लांट वाज डन बाय मेकॉन, आई वाज इन मेकॉन अर्लियर। तो वो अभी नॉन ऑपरेशन ओनली बिकॉज ऑफ वन स्मॉल फायर दैट हैपेंड। उसके बाद सबने उसको छोड़ दिया। चाइनीज प्लांट था, 15 साल से बंद पड़ा है।
आपका जो 50 चौरंगी है जहाँ पर मेकॉन का ऑफिस है और सामने का, ये सब मेरे डिजाइन, मेरे बनाए हुए हैं।
अरे वाह, ग्रेट।
ऑन बिहाफ ऑफ पोतर, बहुत साल पहले 1977 78, 50 चौरंगी तो 1975, सामने वाला ब्लॉक जो इसको का है, इसको का है, और पीछे वाला 1978 डिजाइन कंसल्टेंसी।
दैट एरिया इज हैविंग हिस्ट्री भाई। जा करके वहां पे अलग फीलिंग आती है।
और मेरा 53 इयर्स ऑफ कैरियर हो गया है।
अरे वाह, ग्रेट।
आपका इंडोर स्टेडियम जो वर्ल्ड रिकॉर्ड है, जो 6 मंथ्स में डिजाइन करके कंस्ट्रक्शन किया गया था मैडम के लिए, इंदिरा गांधी के लिए, फॉर द वर्ल्ड टेबल टेनिस, वो भी अपनी हाथ का है।
अरे वाह। तो दर साहब का एक प्रेजेंटेशन कराओ भाई।
करेंगे, हमने ऑलरेडी बोला है जैन जी को, मैं करूंगा। एक थोड़ा सा टाइम मिल जाए, मैं नेक्स्ट मंथ उसके बाद वाले में करेंगे, जरूर कर। हम करेंगे आपको आर्किटेक्चरल इंजीनियरिंग के ऊपर।
आपका पीपीटी बनाने का काम हम लोग करा देंगे, आप हमको मटेरियल दे दीजिएगा।
मैं आर्किटेक्चरल इंजीनियरिंग के ऊपर करूंगा, जो कि दिस इज द टॉपिक नाउ।
बिल्कुल बिल्कुल,
उसके ऊपर करूंगा।
ठीक है, आप तैयारी कर लीजिए एंड डू लेट अस नो।
ठीक है,
विल बी अ प्लेजर।
ठीक है, थैंक यू सो मच सर, एंड इट वाज अ वंडरफुल प्रेजेंटेशन सर, वी लाइक्ड इट, आई लाइक्ड इट।
थैंक यू वेरी मच।
थैंक यू सर, मिलते हैं अगले संडे।
सर दीक्षित सर, that your telephone number कुछ मिलने के लिए चांस है क्या?
अरे व्हाई नॉट, अभी नोट करना है तो मैं अभी बोल देता हूँ.
हाँ, प्लीज 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 प्लीज.
It is 93137
137
491
1
44.
44. Okay, sir. Thank you. Thank you.
Okay.
काफी इंफॉर्मेटिव सेशन रहा सर आज का. एंजॉय किया सारे पार्टिसिपेंट्स ने. थैंक यू
नहीं,
सर.
दैट इज माय प्लेजर. 24 घंटे की नोटिस में अच्छा तैयारी
काफी
हमने कर ली थी,
जी.
तो दैट हेल्प. और अभी हमारा डीकार्बोनाइजेशन वाला सीरीज है ना, इसको हम लोग कंटिन्यू रखेंगे. अभी हमने पहले स्टील सेक्टर किया, फिर
जी.
हमने हाइड्रोजन किया, विच इज अ वेरी बिग थिंग टू डीकार्बोनाइज. ऐसे ही अगर किसी को कोई आइडिया आता है तो इसकी हम सीरीज को चला करके मे बी वी डू समथिंग वेरी गुड. ठीक है युवराज जी, कंक्लूड करिए.
ठीक है सर. थैंक यू एवरीवन.
Thank you very much.